What impact does this modularity have on obsolescence management?
Well, so obsolescence is a big problem for test systems, especially in aerospace where they have to last 10, 30 years or more, right? And so when you've got a part that goes bad in a test system, there's a good chance you're not going to be able to get it anymore on the market. It's going to be replaced with something else. So if that component needs to be replaced with a newer version of the product, and it is not modular, that means there's going to be a cascading series of impacts into the test system design itself. And if you try to go back and modify a test system that's already 20 years old, you're going to have a lot of problems. So typically, aerospace industry just says, well, I got to have parts that go in the system, and I'm going to have them on a shelf for 30 years. That's a huge cost to it. Now, when you have a modular component that has a standardized interface, right? So standard software driver interface, standard hardware interface, you can just swap that out and replace it with a successor item, and there's really no impact to the design of the test system. So the modularity encapsulates your obsolescence strategy by default.
What about my existing software test scripts?
Well, so aerospace companies run a lot of the same types of tests on their products, right? So those existing scripts represent a huge investment, and that's not something you just want to lose or throw away. So what our test equipment allows you to do is have a very strong hardware abstraction layer, right, between your software environment and our hardware platform. So when the hardware matures and upgrades over the years, you can change and upgrade that without impacting your software environment. So those test scripts can still continue to run for years and years, even on different or newer hardware.